All right, last quick set of definitions. An expression of the form where our lower limit is an integer like k equals 1, but our upper limit is infinity. This is called an infinite series. In other words, the summation goes on and on forevermore. If it is what we call convergent, that means that it approaches a finite number, okay? Think about when we're talking about our asymptotes, especially like our horizontal asymptotes. It may never equal that number, but it's getting closer and closer and closer to that value. So it's converging onto an actual integer or an actual finite number. It may not be an integer, but a number. If it is divergent, I heard that was a good meaning. If it is divergent, then it approaches either infinity or negative infinity, okay? So it keeps just getting bigger and bigger in one direction or another, okay? If your common ratio, the absolute value, is less than 1, then the infinite geometric series, okay? So that's an important thing here. It is a geometric series, converges. And we can actually find the sum by taking the first term and dividing it by 1 minus r. On the contrary, if the r is larger than 1, then the series diverges. In other words, it goes either towards infinity or negative infinity. So in example 3, they want us to determine whether this infinite geometric series, notice the sum goes on and on forever, converges to a number or is divergent, in other words, goes on and on forever. If it's convergent, find its sum. So remember, looking at our r value, think of it in terms of an exponential function. If it is decreasing in value every time, right? If it's a decreasing exponential function, then that means the numbers are getting smaller and smaller and smaller. So you could theoretically add them up and getting closer and closer to a number. It's approaching a number. Whereas if it's a growth exponential, if it's an increasing exponential, the numbers are just going to keep getting larger and larger, and therefore the sum is going to keep getting larger and larger. So if we look at our r value here, it is 1/5, okay? That 1/5 is less than 1. Think of it as a decreasing exponential function. So that means it is convergent. So we're going to use our formula where we take our first term and divide it by 1 minus r. That means we have to find our first term. So again, 2 times 1/5 to the 1 minus 1, that gives us a 0 exponent. So our a1 is 2. Okay. Remember, 2 is our initial value. a1 works. And our r is 1/5. So plug both of these in. You get 2 over 1 minus 1/5, which equals 2 over 4/5, which equals 5/2. So if we were to add everybody up in that series, it would, that sum would be getting closer and closer and closer and closer to 5/2. Now let's take a look at B. Are these values getting larger or smaller? They're getting larger. We have 1, and then 7/2 is what? 3.5. So just right there, it's getting larger. But we have to find our r value anyway, just to be sure. But remember, it would be 7/2 divided by 1. So we have a common ratio of 7/2. And we can double check, making sure that's still true. If we took that 7/2 and multiply it by 7/2, we would in fact get 49/4. So that is our ratio. Our r of 7/2, is greater than 1. Therefore, this guy is divergent. That sum's just going to keep on growing because the numbers keep growing. So that's it for section 11.4. Guys, we are done. Yay! I'm so proud of you guys. And again, thank you, Dr. H, for doing all of these closed captioning for us. You've been an absolute lifesaver. So if you have any questions or you just want to say hi, please stop by my office hours. I miss you guys. Talk to you soon. Bye.